Hello friends. Today, I will show you how to implement two-way communication between ESP32 and localhost. This is a step-by-step tutorial, and I will teach you everything that is required for this project. So let's get started. Before we begin, make sure you are familiar with setting up XAMPP software and creating a database using the MySQL server. If you are new to these concepts, then I have a detailed video on my channel that covers the entire process step by step. You'll find the link in the description below. Next, let's quickly have a look on what I will be covering in this tutorial. First, to implement the two-way communication, I will be using WebSocket. WebSocket is an excellent choice for this project, as it enables real-time and bidirectional communication between the ESP32 and the localhost server. Next, I will explore different WebSocket client software options. I will show you how to connect to the WebSocket server using these clients and send messages to different clients connected to the server. Next, I will build a custom WebSocket client using JavaScript. This will give us more flexibility and control over the communication. Next, I will show you how to create a WebSocket client on ESP32. It will be used to send and receive data between ESP32 and localhost. Finally, I will make a project using ESP32 and localhost. This will be a fully functional project with all the technologies we have discussed above. This is the complete overview of this video. Now let's move to the first section of the video. In this section, I will explore the fundamentals and the functionality of the WebSocket. WebSocket are a powerful communication protocol that enables real-time, bidirectional communication between a client and a server. It establishes a persistent connection. It means once the connection is established, it remains open. It allows continuous communication between the client and the server. WebSockets are supported by modern web browser and can be used in web applications built with JavaScript. Additionally, there are WebSocket libraries and frameworks available for different programming languages, making it possible to implement WebSocket communication on the server side as well. One of the key advantages of WebSockets is the ability to connect multiple clients to the WebSocket server. Each client can send messages to the server, and the server receives these messages and broadcasts them to all connected clients. This broadcasting ensures that all clients, including the one who sent the initial message, receive the updated information in real time. To implement the WebSocket server, I will use PHP scripting language. This language comes with XAMPP, so you do not need to install it separately. To create a WebSocket server, I will use a highly recommended PHP library called Ratchet. It is a widely used PHP library for building WebSocket servers. It's important to note that manual installation of the Ratchet library is not possible due to its dependencies. These dependencies are defined in the composer.json file. You also need to install all these dependencies to work with this library. To simplify the installation process and ensure all dependencies are properly installed, I will recommend using Composer, which is a powerful dependency management tool. The Composer will automatically download and install all the necessary components, making it the best approach to installing the Ratchet library along with its dependencies. You can download Composer from the website getcomposer.org. The installation process is straightforward and user-friendly. You just need to select your PHP installation path. If you are not sure about the path, then navigate to the installation directory of XAMPP. Here, look for a folder named PHP. And inside this folder, locate the file named php.exe. Now the PHP path is selected, you just complete the installation process. After installing the Composer, open the command prompt or terminal window, and execute the following command: Composer-V This command will display the version of the Composer software. If the version is displayed, it means the Composer has been installed successfully. Before installing the Ratchet library, you will need to create the project folder. So, navigate to the XAMPP installation directory on your C drive. Here, open the htdocs directory. Inside this directory, I will create my project folder. You can give any name to the folder, but for this project I will give it the name Project 1. Now, open this folder. And inside this folder, create a PHP file named index.php. Then, open the file with your favorite code editor. Here I will write a simple code to display a greeting message. To display text on the web page, you can use the echo command. Now press Ctrl+S to save the changes. You can test the code by using a web browser. In the address bar of the browser, enter localhost, then project 1, which is our project folder. And then enter the file name that we have just created, which is index.php. This error indicates that the localhost server is not running. To start the server, you just open the XAMPP control panel from the XAMPP installation folder. Here, you need to start Apache server and MySQL server. When both services have a green status, it indicates that they are running properly. Now, move back to the web browser and refresh the web page. You can see the greeting message is displayed on the web page. Next step is to install the Ratchet library. So open the command prompt again. Here, first navigate to our project folder, which is located inside the htdocs folder. Now we are inside our project folder. Now I will execute the Composer command to install the Ratchet library. The command is composer require cbodin/ratchet. Press enter to execute the command. It will start installing the Ratchet library along with all the dependencies. The library has been installed. You can verify it from the project folder. Here you can notice some new files have been added to our project folder. And inside this vendor folder, you can find the Ratchet library and all its dependencies. Now we have successfully installed the Ratchet library. Next step is to create WebSocket server. To do this, create a new PHP file inside the project folder. Name this file websocket.php. And then open this file using your favorite code editor. Here I will write some code to create the WebSocket server. This code will define the behavior and functionality of the server. First, I will include the autoloader file from the Ratchet library. It will automatically load the required classes. Next, I will import the necessary classes from the Ratchet library. We will use these classes in our code. Then I will define a class called myWebSocket. This class will be responsible for handling WebSocket events and messages. Inside this class, I will declare two properties. The first one is clients. It is an object storage property, which will hold all connected clients. Next, I will define an array called connected clients. This array will keep track of all the connected clients. After that, I have defined a constructor for my WebSocket class. In this constructor, I have initialized the clients and connected clients properties to null. Next, I will define the first method of WebSocket class, which is onOpen function. This method will automatically execute when a new client tries to connect to our WebSocket server. Inside this method, the first step is to attach the client to our WebSocket server. This code ensures that whenever a new client attempts to connect to the WebSocket server, it will successfully attach to the server. After connecting to the client, I will store it in the connected clients array. This array will hold all the clients connected to the WebSocket server. To provide a visual indication of a new connection, I print a message in the terminal window using the echo command, indicating that a new connection is established. Additionally, I will send a welcome message to the client using the send method, ensuring the client will receive a warm greeting upon connecting. This is the minimum setup required to connect to the WebSocket server. However, you'll need additional functions as well, such as the onMessage function. This function is automatically called when a client sends a message to the server. You will also need the onClose function, which will automatically called when a client disconnects from the server. Finally, you will need the onError function. This function is called if an error occurs during the WebSocket connection. In this case, I will handle the error by printing an error message in the terminal window, using the echo command. And then I simply close the connection, by calling the close method on the connection. Next, I will create an instance of the Ratchet app class, which represents our WebSocket server application. This class required some parameters. The first one is the IP address. This is the IP address on which the WebSocket server will be bound. In this case, the server will be bound to the localhost, which means it will listen for connections on the same machine, where the server code is running. The second parameter is the port number, on which the WebSocket server will listen for incoming connections. In our case, the server will listen on the port number 81. Ports are like door numbers on a house. Just as a house can have multiple doors to enter, a computer can have multiple ports to receive different types of incoming data. There are 65,535 ports in a computer. The third parameter is the binding IP address for the WebSocket server. In our case, it is 4 times 0. This special IP address has a unique meaning in network programming. This allows clients from any location or IP address to connect to the WebSocket server without any restrictions. After setting up the necessary parameters, the next step is to define the endpoint for the WebSocket server. Here I have set the server root as a base path or endpoint. To access the WebSocket server, the address starts with WS, which stands for WebSocket. Then, the IP address of the server is specified. And then specify the port number. And finally, the base path. This is the complete address of the server. This address will be used by clients to establish a connection to the WebSocket server. Next, I will start the WebSocket server by calling the run method of the app instance. This method starts the server and makes it ready to receive incoming connections. Now the code is ready. Let's start our WebSocket server and see it in action. To start the server, open your command line interface and navigate to the directory where we have saved the websocket.php file. Here run the following command: php, then enter the file name of WebSocket server. In our case, it is websocket.php. Press enter to start the server. The server is now running and waiting for the incoming connections. Next, let's test the server using a WebSocket client. I will use a browser-based WebSocket client to test the server. Here I will install this simple WebSocket client extension for Google Chrome browser. It is a reliable and user-friendly extension that simplifies the testing process. However, feel free to select any WebSocket client extension that you like the most. Now the extension is installed. You can open it from the extension menu of the browser. This is the home page of the WebSocket client extension. Here, you'll find an address bar where you can enter the WebSocket server address. In our case, the server address is localhost, the port number is 81, and then enter path, which is just a /. Then click on the Open button to establish a connection with the WebSocket server. The connection is successfully established now. If you look at the terminal window of the WebSocket server, you will notice a new connection is established. Additionally, in the client window of the WebSocket client extension, you will notice that the client has received a welcome message from the server. These messages are printed from the onOpen function of the WebSocket server. If you look inside the onOpen function, you can see this echo statement that prints the new connection message in the terminal window of the WebSocket server. And below this send message function, sends a welcome message to the newly connected client. Let's move back to the WebSocket client. Here I will send a hello message to the server. As you can see, the client does not receive any response. This is because I have not yet implemented the onMessage function of the WebSocket server. I will implement it later on. If you want to close the connection, you can click on the close button. However, if you look at the terminal window, you will not see any indication of the connection being closed. This is because I have not implemented the onClose function of the WebSocket server yet. So let's implement the onClose function first from the code. Within the onClose function, I will simply display a message that says, the connection is closed. Additionally, I will call the close function of the WebSocket server. But I think it is not required because the connection is already closed. Now let's move back to the WebSocket client. Here, first I will restart the server. You can terminate the WebSocket server by press Ctrl+C on the keyboard. And then start the server again, using the same command that we have used before. It's important to restart the server after making any changes to the server code. Now, first I will establish the connection by clicking on the Open button. And then I will close the connection by clicking on the same button again. Now if you look at the terminal window, you will notice that the connection is now closed. Currently, I am testing this project using the same computer, where the WebSocket server is running. However, to ensure working of the server, I will now use my Android phone to test WebSocket server. Here I have installed an app called WebSocket Tools from the Play Store. I will use this app to establish a connection to the WebSocket server. Make sure your Android phone and the computer running the localhost server are connected to the same Wi-Fi network. Here, enter the IP address of the computer where the WebSocket server is running. Then, tap on the Connect button to establish a connection to the server. But here you can see, the client has failed to connect to the WebSocket server. This is because accessing the localhost from the network is not possible. To successfully access the server, you will need the IP address of the computer. To obtain the IP address of the computer, you can execute the ipconfig command in the command line interface. Here is the IP address of the computer. And I will use this IP address in the WebSocket server code, instead of using the localhost. This way you will be able to access the server from any device connected to the same network. After making this change in the server code, it is necessary to restart the WebSocket server to apply the modifications. Now I will try to establish a connection to the server using the updated IP address. As you can see, the connection is successfully established. Now, let's test it from a mobile device. Please ensure that your Android phone and the computer running the localhost server are connected to the same Wi-Fi network. As you can see, this time the connection is successful, and I have received a welcome message from the server. This way you can connect any device to the WebSocket server. Next step is to implement the onMessage function of the WebSocket client to enable communication with all the clients. This function is automatically called when a new message is received. It has two parameters. The first parameter is the from object, which contains information about the client who sent the message. The second parameter is the message variable. It holds the actual message sent by the client. Inside this function, I will loop through all the connected clients using the for loop. This connected clients array contains information about all the clients that are currently connected to the server. This array is initially populated in the onOpen function. Here, when a new client connects to the server, it will be added and stored in the connected clients array. This allows us to keep track of all the clients that are currently connected to the server. I have used the same connected clients array inside the onMessage function. And inside the for loop, I will broadcast the received message to all the clients connected to the server, including the client who initially sent the message. This ensures that all clients receive the message simultaneously. Now the code is ready. To apply the changes, it is necessary to restart the server. Next, let's establish a connection to the server and send a message. I will send the message hello to the server. As you can see, the server responds with the same message. This is because, when the server receives a message, it broadcasts that message to all connected clients, including the client who initially sent the message. To verify if the server has successfully received the message, you can use the echo command to print the message in the terminal window. This will confirm that the server has received the message as expected. Now, let's test the server once again. I will send the message hello to verify if the server is receiving the message correctly. As you can see, the message is printed in the terminal window, confirming that the server is successfully receiving the data. Let's perform one final test using the mobile device. I will send the message hello to the server using the mobile phone. As a result, you can see that the data is received by all the clients, as well as the WebSocket server. Now we have successfully tested the bidirectional communication between clients and the server. Next step is to make a custom WebSocket client using the JavaScript. So let's move to the project folder. Inside the folder, you will find an index.php file that we created earlier. You just open this file using a code editor. In this file, I will create a WebSocket client. First, we need to write some basic HTML code. I have already written the code for you. It simply displays project 1 in the title bar of the web browser and shows a hello message on the page. Now, let's test this page to see how it looks in the web browser. In the address bar, enter the address of your project folder, which is project 1. Then, enter the file name, which is index.php. You will see that the hello message is displayed on the page, and the title bar shows project 1. Let's move back to the code. I will now implement the WebSocket server using JavaScript. So I have included the JavaScript tags for writing the code. Within these tags, I will establish a new WebSocket connection. I will provide the address of our WebSocket server and specify the port on which the server is listening. With this single line of code, the connection will be established seamlessly, without requiring any additional code. Now let's test the connection. To do this, you'll first need to open the console. So right-click anywhere on your Chrome web browser, and then select Inspect. The Inspect option is available in developer tools provided by Google Chrome, Firefox, and other web browser. From the Inspect tool, choose the Console tab. The console provides a convenient way to view the messages received from the server. You also need to open the command prompt to monitor the connection information on the server side. Here, I have encountered an error. The WebSocket connection is failed. I think I forget to start the server. So I will quickly start the server from the command prompt. And then, I will again test the project. This time, the connection is successfully established, as you can confirm from the server side. However, the welcome message is not being received in the console. To receive messages from the server, you will need to implement the onMessage function in the JavaScript code. Within this function, I will print the received message to the console. When data is received from the server, it's stored in the event object. And I will use this event object inside the log function to display the data on the console. Let's move back to the web browser to test the code. This time the code runs successfully. As you can see, the welcome message is displayed in the console. Now we have our own client to communicate with the server and other clients. It is important to note that you don't need to restart the server, since I have not made any changes to the server-side code. Next, I will start working on a complete project that involves connecting and communicating with an ESP32 device. The ESP32 will send temperature and humidity data to the client, which will be displayed in the temperature and humidity section. Additionally, the project also have a button. When the button is pressed, the LED connected to the ESP32 will turn on. The status of the LED will be displayed on the button. Let's move to the index.php file to create the web page. Here, I will write some HTML code to create different sections on our web page. In the first section, I will display the temperature. And I have set the initial temperature value to 0 degrees Celsius. Next, I will create a section for humidity data. I have also set the initial value of humidity to 0. Finally, I will create a button using the button tag. Here I have set the label of the button to off. Now, let's talk about the onClick attribute. This attribute is triggered when you click on the button, and it allows us to execute some code. So I will use it to display an alert message. For testing purpose, I will display hello message in the browser. Let's test it in the Chrome browser. Here I will observe the functionality of the button by clicking on it. As you can see, a hello message is displayed as an alert. This way you can use the button to run any code. Now, I will use the onClick event of the button to write code for sending data to the server. First, I will add a function in the onClick event, which is called toggle. And then, I will define this function inside the script tag. And inside this function, I will create a button object, and initialize it with the LED button. To get the button element, I have used the getElementById method. And I have set the parameter of this method to LED button. If you look at the button tag, you will notice that I have defined the ID to LED button. Therefore, this entire button tag can be accessed using the button instance that I have created inside the JavaScript. Next, I will read the status of the button by using a condition. Here I have highlighted the condition. This condition will check the label of the button. As you can see, the initial label of the button is set to off. So, this condition compares the button's label with the string off. And if the condition is true, it means the label of the button is off, and in this case, the value 1 is assigned to the status variable. On the other hand, if the condition will false, then the value 0 will be stored in the status variable. In our case, the status of the button will be 1, because the initial value of the button is off. Now, I will send this status to the server, using the send method of the WebSocket client. Inside this function, I will send the status of the button to the server, along with some additional information, such as LED. This project deals with data from two different sensors, LED and DHT11 sensor. Therefore, it is necessary to include the sensor name when sending the data. Here, the status belongs to the LED sensor, so I have appended LED after the status. Next, I will specify the device name where I am sending the data. In our case, the data will be sent to the ESP32. Finally, I will specify the sender name. Since the data is being sent from localhost, so I will write localhost here. The complete message will look something like this. When I press the button on the web page, this toggle function will be executed, because I have set it as the onClick event for the button. Let's test it out. Here I will observe the functionality of the button by clicking on it. As you can see, the message is displayed in the console, with the same format I have defined in the toggle function. This message is broadcasted to all connected clients. Therefore, if the ESP32 is connected to the server, it will also receive the same message. Next, I will pass this message to extract the data from it. I will use this data to toggle the state of the button. The onMessage function handles the received data. So here I will use the split function to separate the data into parts. This function will split the data into parts on the basis of colon delimiter. Next, I will store this data in variables. The actual message will be stored in the message variable, and the sensor data will be stored in the sensor variable. Next, I will use an if condition to check if the sensor is equal to LED. And if it is, then I will write some code within the if statement to toggle the state of the button. So, first I will get the button element by using the getElementById method. Then, I will toggle the state of the button by using a condition. This condition will compare the message variable with the value 1. And if the condition is true, then the button will display the text on. On the other hand, if the condition will false, then the button will display the text off. Now let's test it. Here I will observe the functionality of the button by clicking on it. Here you can see, our button is toggled perfectly. Now we have fully functional button to control the LED connected to the ESP32. Next, I will write some additional code to handle the temperature and humidity data. So, below the button code I will use another if condition to check if the sensor value is equals to DHT. Just like I have used the sensor name LED for sending the LED status. The same way, when I will send the temperature data from ESP32, then I will use DHT as the sensor name. And this data will be received to the index.php file. And here I have used an if condition to check if the received message belongs to the DHT sensor. And inside this if condition, I will use the split method to separate the temperature and humidity data from the message variable. And then I will store these separated values in two separate variables. And then, I will update these values on the web page. If you inspect the HTML code for the temperature element, you will notice that its default value is set to 0. I will update this value with the newly received temperature value. The ID of this element is temperature. Similarly, the default value of the humidity element is also set to 0. And the ID of this element is humidity. So to access these elements within the JavaScript code, I will use the getElementById method. Here, first I will access the temperature element using the getElementById method. Then, I will update this element with the temperature data received from ESP32. Similarly, I will update the humidity element using the same technique. Now, let's test the code. Make sure the WebSocket server is running. Then just click on the refresh button to test the code. Here we have an error. The error is in the index.php file, at the line number 29 and the column number 69. So let's examine the line number 29 from the index.php file, specifically look at column number 69. Here, I just forget to add the plus operator, since I am appending a variable to a constant string. Additionally, I will add the % symbol in the humidity element. Now, let's test it again. This time the connection is successful. To send data to this client, I will use another client, the WebSocket client extension for the Chrome browser. Here I will send the fake temperature data which is 33.66, and the humidity data which is 54.34. Additionally, I will enter the sensor name as DHT sensor. I will not add any sender or receiver name, since I am just testing the code. Perfect. The data has been successfully updated on the receiver side. Let's do it one more time, but this time with different temperature and humidity values. As you can see, the data is received in real time. The same way, you can toggle the button state. If I will send 1, with the sensor name LED, then the button will toggled on. And if I send 0, then the button will off. Now, I will implement this knowledge in the ESP32 code. So just connect the ESP32 to your computer, and open the Arduino IDE. Here, you will need to include the necessary libraries. Wi-Fi library is the built-in library for ESP32, so there's no need to install it separately. Then, you will need to include the Arduino WebSocket library. You can download it from the GitHub repository. I will provide the link within the code. After including the WebSocket library, I will use it in the code. Here, first I will create an instance of WebSocket client. This instance will enable communication with the WebSocket server. Then, specify the address of the WebSocket server. You just enter the IP address of the WebSocket server along with the port number. In order to track the connection status with the WebSocket server, I have defined a Boolean variable. It will be used to monitor the WebSocket server connection effectively. Additionally, you will need to provide the SSID and password of the Wi-Fi router, to which your web server is connected. Within the setup function, first I will start the serial communication with the computer. Then, I will establish a connection to the Wi-Fi network using the connect to Wi-Fi function. I have already created this function. So I will just place it below the loop function. This function contains the standard code required to connect to the Wi-Fi network. After establishing the Wi-Fi connection, I will establish a connection to the WebSocket server, using the connect function of the client. Here, you will need to specify the WebSocket server address. I have already defined the address of the WebSocket server, so the ESP32 will automatically connect to the server using this address. Then, I will display a message on the serial monitor, to provide a clear indication of the success or failure of the connection. To improve code readability, I will create a separate function to connect to the WebSocket server. And then, I will place all the relevant code within this function. Finally, I will call this function within the setup function, to establish the connection to the server. Now the code looks clean and readable. Next, I will write the necessary code to handle incoming messages. When a message is received from the WebSocket server, then this handle message function will be called automatically, to handle the incoming messages. I will define this function later in the code, to properly handle the incoming messages. Similarly, I will write the necessary code to handle event messages. When an event occurs on the WebSocket connection, such as a connection being opened or closed, then this handle event function will be called automatically. Next, I will define the handle message and the handle event functions. Below the loop function, I will begin by defining the handle message function. When the data is received from the server, it will store in this message variable. And within this function, I will just print the contents of the message variable on the serial monitor. Then, I will define the handle event function. I will implement this function later in the code to handle various WebSocket events effectively. Next, within the for loop, the first step is to check if the ESP32 is currently connected to the server. If the connection is not established, then the code will enter inside the if condition. To provide feedback to the user, I will print message on the serial monitor to indicate about the connecting process. Then, I will try to connect to the server, using the connect to WebSocket function. Finally, it is required to call the poll function of the WebSocket client. This function continuously listens for incoming messages and events. When a message or event occurs, the poll function will transfer control to the appropriate function to handle the incoming event or message. Now the code is ready. Before uploading the code, it is important to review the compile configuration from the Tools menu. Additionally, it is necessary to install the ESP32 core from the board's manager. Make sure to use the same version as the one specified here. Let's upload the code to ESP32 to test its functionality. After uploading the code, open the serial monitor. Make sure you have started the WebSocket server from the command prompt or the terminal window. As you can see, the connection to the WebSocket server is established. It means the code is functioning perfectly. For the final test, I will open the index.php file. Here, I will click on the button to send the LED status data to the ESP32. As you can see, the ESP32 is receiving the data in real time. Next, I will add some more code to the sketch file in order to send data to the server. Within the loop function, I will use the send method of the client to transmit the data. Initially, I will set the LED state as 1. Since this data is related to the LED, so I will write the sensor name as LED. The remaining options are straightforward, as the data will be sent to the localhost from the ESP32. Then, I will add a 1-second delay. After that, I will send the LED data once again, but this time I will set the LED state to 0. Then, I will add another 1-second delay. Now, I will send some fake temperature and humidity data. This time the sensor name will be DHT. The other options will remain the same as before. Finally, I will send additional temperature and humidity data to the server. I will also add a delay of 1 second. Now just upload the code. After uploading, open the serial monitor to monitor the output. First I will reset the ESP32 and wait for the output. As you can see, the server starts receiving the data sent from the ESP32. Let's test it from the index.php file. Here you can see, the index.php file start receiving the temperature data from the ESP32. Additionally, if you look at the button, you will notice that it toggles perfectly. Now let's move back to the code. This time, I will send real temperature data from the DHT11 sensor. So first, include the popular Adafruit DHT sensor library. Next, define the pin to which the DHT11 sensor is connected, which is pin 19 on ESP32. Additionally, specify the type of the sensor as DHT11. And then, create an instance of the DHT sensor to communicate with the sensor. Then, define two variables to store the temperature and humidity data. Within the setup function, start the DHT11 sensor using the begin function to initialize its operation. Inside the loop function, I will call load DHT data function to get the latest data from the sensor. And this data will be stored in the DHT data variable. I will define the load DHT data function at the end of the sketch file. This function have a sample code to read the latest data from the DHT11 sensor. Now, let's send the real-time temperature data to the WebSocket server. So, just delete this fake data, since we now have the actual temperature data. And you will need to append this data to the message. Let's upload the code. As you can see, now the real temperature and humidity data is start displaying in the serial monitor. Let's look at the index.php file to observe the DHT sensor functionality. I will test the DHT sensor using the hot air to observe the real-time update of the data on the web page. As you can see, the temperature value starts to increase. Let's implement the functionality for the LED. I will use the built-in LED connected to the pin 2 of ESP32. Then I will define a variable to store the status of the LED. Within the setup function, set the pin mode of the LED pin to output. Initially, the LED should be set to the off state. When we press the button on the web page, then the data will be received to the handle message function from the onMessage function. Now, let's focus on the handle message function. Within this function, the first step is to store the incoming message in the data variable. Then, the passData function is used to extract the LED status from the message. This is a custom-made function, and I have implemented it at the end of the sketch file. The purpose of this function is to extract data from the incoming message. Let's move back to the handle message function. The next step is to extract the sensor name from the message. Then I will use an if condition to check if the sensor is equal to LED. If it is, then I will update the current status of LED with the newly received status value. Finally, I will use digital write function to toggle the LED based on the status variable. Now, let's test the code. Here you can see, I am perfectly controlling the built-in LED of the ESP32 using the button. Now I will make a final change in the code. This time I will use the boot button of the ESP32 to control the LED. And also I will update the status of the button on the web page. First, I will define the boot button pin, which is pin 0. Then, I will set the pin mode of the button to input pull-up. Then, inside the loop function, I will read the status of the button. If the status of the button is low, it means the button is pressed. So, first I will add a delay of 200 milliseconds to handle the button debounce. Then, I will update the LED status and toggle the LED using the digital write function. Finally, I will send the LED status to the server. Now the code is ready. Let's test it. If I press the boot button on the ESP32, then the LED will turn on. And if you look at the button on the web page, its status is updated perfectly. Now, we have successfully implemented two-way communication on the ESP32. You can now utilize this knowledge to create your own custom projects. I would appreciate your feedback in the comments regarding the type of project you'd like to create using this tutorial. If you're interested in sending data to the local host using an HTTP request, I highly recommend watching this video, which offers a detailed introduction to the localhost, PHP, and MySQL database. If you have any questions, feel free to ask in the comment section below. Bye.